Good afternoon, everyone, and thank you for joining us. So my name is Keegan Evitz. I'm with ICF. We're the vendor working on behalf of the sponsors of Energize Connecticut to bring these passive house and all electric homes trainings to all of you. So thank you for joining us today. Thanks to Steve for joining us as well. These trainings are at no cost to you all, thanks to the sponsors of Energize Connecticut, and are part of a partnership with Connecticut Passive House. Today's training will be recorded and will be made available online afterwards. We'll share that link with everyone who attends. A reminder that as part of this training and workforce development initiative, the sponsors of Energize Connecticut also offer a 75% cost reimbursement for individuals pursuing either FIAS or PHI professional accreditation. This includes the cost of the trainings and the exam, and once you become fully certified, we will work with you to process the cost reimbursement. So if you have any questions about that, you can contact us. And in addition to the training series and the professional accreditation reimbursements, the sponsors of Energize Connecticut also offer incentives for builders and developers who choose to go either all electric with their residential buildings or pursue passive house certification in multifamily projects with 5 units or more. Steve, go back one.
Sorry about that.
Yep. So the passive house incentives design is shown here. It includes incentives for pre-construction items like feasibility studies into whether passive house is feasible for your project, and energy modeling, and post-construction incentives for full passive house certification through either FIAS or PHI. The all-electric incentive, if you want to go to the next slide now, is for both single-family and multifamily buildings with 2 levels of eligibility with specific design and performance requirements associated for each. The incentive amounts range from $1,500 a unit for multifamily up to $10,000 for single-family homes. Our goal ultimately is for everyone involved in the construction of residential buildings in the state of Connecticut to be aware of these incentives. So if you're interested in learning more, please visit the Energize Connecticut website or contact us directly after the presentation today. Now, as for questions during today's session, please feel free to use the chat function throughout. So the questions pane on your GoToWebinar control panel, and I will relay them to Steve. And so with that, I will turn it over to our presenter today, Steve Klocke from Stephen Winters Associates. Steve, thank you for joining us. Take it away.
Thank you, Keegan. I'm happy to be here. I'm with, Stephen Winters Associates. Some of you may have heard of us. We are energy raters, consultants, verifiers, building subject experts or subject matter experts in a bunch of locations up and down the East Coast. You guys, you're here today to hear about air sealing in multifamily buildings, also known as compartmentalization. And we are specifically going to talk about wood frame buildings. It would be helpful for me to know who is attending. Would you all, if you don't mind, put your role into the chat box? So are you a builder? Are you a rater? Are you an architect? Are you an engineer? Other person related to the industry, or just curious about what we do? Could you do that right now? And I'm hopefully going to see that. Oh, good. Awesome. I need to stretch my window out here so I can see more at once. Keegan, I may need help with that. I can only see one answer at a time.
Yeah, use the little box with an arrow pointing diagonally. If you press that, it'll pop that window out, and then you can stretch it.
Beautiful.
All right.
Okay. Jennifer, I think we're only seeing, hopefully you should have seen the slides change. If not, give me another message. Okay, so we've got rater, owner, general contractor, architectural designer, architect, code official, program manager, architect, contractor, developer, owner, construction manager, consultant. Great. Okay. Please, if you haven't responded, go ahead and do that. But so none of this is surprising. This presentation should have something for all of you. And if it doesn't, by all means, like Keegan said, raise your hand or type a question into the questions box, and I'll help you out. This is going to be not super formal. It does get pretty technical. I will scratch out some details for you here and there if we've got time at the end. We usually don't, because people usually will jump in with questions and we just kind of keep the conversation going that way, which is totally great. But anyway, we can scratch out more details at the end if you have specific questions about specific assemblies. So let me see. So basically, a long time ago, the building science gurus figured out that to stop heat loss or heat gain, you need to stop air movement. It's pretty simple. So that pertains to, that's a very simple answer to the question. There's actually several reasons why we like to air seal in multifamily buildings. The first one, obviously, is to save energy. You're looking at an infrared image of PTAC, through wall air conditioner unit. White and red are hot, or warm, I should say, and blue is cold. So you're basically just seeing there's a lot of air coming through there, and there's also obviously conduction of heat. But like I said, the best way to save energy is to minimize air leakage. It also is a great way to overcome stack effect, which accentuates air leakage. So this is your average, mid-rise building where we have stack effect working through the whole building. And we're looking at, let me use my little pointer here. We're looking at this building as one big bubble, okay? You have, everybody knows heat rises, and that's called the stack effect. What's happening in each individual apartment is in the lower half of the building, you have air coming in to make up for the negative pressure here. In the middle of the building, we have what we call a neutral pressure plane, where there really isn't a pressure difference between inside and outside, because the pressure is changing from negative to positive as it comes out the top of the building. So you can see these little arrows here indicate that air is actually leaking out of these units, whereas air is probably leaking into these units. If you want to go back to the previous slide, that has a lot of bearing on what has happening at your PTACs any time of the year, depending on how far you are up in the building. Okay, so there's your stack effect. Here's what's happening in the big bubble and little bubbles. And what compartmentalization means is like actually making each apartment its own little bubble. A building is made up of lots of interstitial spaces, but by compartmentalizing, by reducing air leakage in and out of each apartment, you are turning this one big bubble into, you're breaking it up into lots of smaller, tightly sealed bubbles. And what that does is it knocks down the driving force of stack effect. So it actually, all these little bubbles, getting them nice and tight, makes the bigger bubble work more efficiently. Hopefully that makes sense. This is a classic image from a colleague up in Vermont. This building was under renovation, and they were heating it, obviously temporarily, and they were rebuilding this section. I think this is around scaffolding. They may have been fixing the masonry, perhaps. But you can see at the bottom of the building, we've got this plastic, wrap around the scaffolding that's getting sucked in, and at the top it's billowing out, and in the middle it's just sort of flapping there in the wind. So that right there is a very clear example of stack effect working in the real world. Also, reducing air movement reduces moisture movement. So this is an image, also pretty old school image from South Face. Here's a 4x8 sheet of drywall, and at interior 70 degrees and 40 degrees relative humidity, doesn't tell us what the outdoor conditions are, but either way, you're going to get a third quart of water diffusing through this 4x8 sheet, 32 square feet of drywall. If you had a 1-inch hole in the middle of that sheet, same conditions, same amount of time, you're losing 30 quarts of water. So that's basically 90 times more moisture is going through this 4x8 foot solid material via that 1 square inch little hole as compared to the rest of the sheet itself. So absorb that one, haha, no pun intended, and keep that in mind as you're worrying about air leakage and how much of an impact it makes and where. Sound and smell transfer is reduced greatly by compartmentalizing. Anybody who's lived in a multifamily building or stayed in a hotel or basically, inhabited any space next to someone else's space, boy, it sure is annoying to have noises come through there when you're trying to sleep or put a kid down or whatever. So, rule of thumb, air is going to move through a hole easier than through a solid material. Same thing for sound and same thing for smells. They're going to move through air leaks much easier than they're going to leak through a solid material. Compartmentalizing also helps us stop flame and smoke spread. This is universally accepted, fire stopping, as a common building requirement and process. So the industry's got its head wrapped around this. And so in the left here, we're looking at putty packs on electrical boxes and I would guess to be a demising wall. And then on the right here, depending on which code official you're working with, he or she may not accept fire foam, as this is called, but this is just blocking what we call draft stopping, actually, in these floor cavities above the ceiling of an apartment. So again, just like sound, just like moisture, just like smells, just like energy, fire and smoke are going to move through a hole a lot quicker than they will through a solid material. Compartmentalizing also improves occupant comfort. Here's another P-tack. And again, if you've been in a hotel or an apartment building and the wind's blowing on this side of the building, and let's say you are in the bottom half of the building in the wintertime, you are going to get a lot of cold air blowing in through this P-tack assembly. And that is not only cold and uncomfortable, but it is not filtered. It is bringing in, again, all the noise and just basically all the stuff that's outside that we usually try to keep away from inside. So lots of comfort benefits to compartmentalizing. You can call this comfort if you want. Also, lack of being grossed out by bugs, maybe not ants, maybe something grosser like cockroaches, going from one apartment to the next. So compartmentalizing also will help you stop pest migration. And of course, you are required to air seal by the Energy Code, Passive House US, Energy Star, LEED, all these codes and certifications require you to air seal. And this presentation, we will try to address all of you as far as whether you're coming at the project from the design side like an architect, or if you are a general contractor or foreman from the construction side. But all of this applies to all of you. It's just a matter of understanding when the spotlight is on you in the building process. So architects will look at some details to get into the drawings. Contractors, etc., will look at some visual guides and best practices for not, for example, losing sleep before you call someone like me to come out and do your blower door testing, which definitely has happened. I'll come to a job site and they'll be on pins and needles and be like, we checked this, we checked that, and they're not sure. They're freaking out. They got people moving in next week, and everybody's got their crosshairs on the construction team's backs to not screw this up. So it's something that you should take seriously, basically, is what I'm trying to say. Okay, so how and where does air leakage occur? For air leakage to occur, you need two things. You need an opening, so cracks, little holes, big holes, sometimes permeable materials, like let's say, for example, fiberglass bats are not an air barrier, right? You will get air leakage through them. So you need an opening and you need a driving force. That's really the two basic things you need for air movement. So going back to that picture of the stack effect diagram where there's a neutral pressure plane, even if there were openings there, if there was no driving force, no air is moving in and out of the building there. So it's probably not going to be common wind or something like that going on, but basically you only need an opening and a driving force. There's a football on the slide because I put the slide together back in the Inflategate days for a presentation in Boston. And so I said to them, okay, look, Patriots fans, if you had a hole, then you had a driving force, such as like someone squeezing a football. That's how you would leak some air out of your balls and win Super Bowls. Hope I don't make any enemies there. Okay, where does air leakage occur? Well, the answer to the question is it occurs there, and 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 there. Basically, it happens anywhere you've got a connection or a disconnect between two materials or two assemblies. So here's an exterior wall on this floor plan. So where the exterior wall meets the demising wall, there's an opportunity for leakage. Where that exterior wall meets an interior partition, opportunity for leakage. Where it meets the window, or around the window, I should say, opportunity for leakage. And then you basically can just carry that around the entire unit. And it can be a bit daunting, honestly, but if you can understand the concept and wrap your head around the concept, it's actually not that hard. Okay, how can we control leakage and provide sufficient air sealing? All right, first let's understand what we care about and why. So if you're not familiar with these terms, ambient, I hope you're familiar with, that's just basically outside your building envelope, that's outside air. Adiabatic describes an assembly that is between two condition spaces. So let's say it's a demising wall. Apartment A's condition, apartment B's condition, there's no heat transfer there. So, but it is part of our envelope of the apartment. So, but just looking at this in concept, so a detached dwelling, let's just say theoretically has 100% ambient exposure, right? An attached dwelling, a dwelling in a multifamily building, actually, based on this size and shape, only has 16% of its envelope exposed to ambient conditions. Now, let me see. It doesn't matter, for the sake of compartmentalization, whether the air is coming from outside or the air is coming from the apartment upstairs, downstairs, to the left, to the right. All air leakage matters when we're talking about compartmentalization. So I'll pause there for a second. All air leakage matters. It doesn't matter where it's coming from. For compartmentalization, all air leakage matters. Okay, there's also two different ways we look at air leakage. There's these two testing metrics here: volume-based metric, which is the ACH 50, like you'd see in residential code, and then there's enclosure area, so that's CFM 50 per square foot. That's what you typically see in Energy Star LEED building code for residential, multifamily, etc. And the 50 here, by the way, is 50 pascals. That's just the standard that we follow for doing blower door tests. If anybody's ever seen a duct leakage test, we do that at 25. We do CFM 25, not CFM 50. It's irrelevant other than the fact that ACH 50 or CFM 50 is at that higher pressure. It's not at natural pressure. So don't let that confuse you. Anyway, looking at these two abstract shapes, they have equal volume and floor area, but this one down here has 9% more enclosure area. So one of our tips for you architects is, hey, make it easier on your construction team in a lot of ways, I think, not just for the sake of air sealing. Don't make funny shaped apartments. Try to make them as cubical as you can. Obviously, the most efficient way to enclose the volume is with a sphere, but we're not quite building that way yet. So cubes are the way to go if you can. Okay, so again, in the vein of simplifying enclosure area, let's look at these two different units in this project. This one down here is a nice, simple rectangle with 4 basic corners, 4 connections of, you know, a demising, corner wall to demising, demising to exterior, etc. This unit up here, which only has, I think, 1 more bedroom, barely 1 more bedroom, has 18 corners if you count it up around the perimeter of this apartment. So it's a dumb question, but you know, which of these apartments will you most likely have an easier time air sealing? It's going to be this one down here. Simpler shapes equal simpler construction, which in my opinion means more success. So architects, if you can, keep your layouts as simple as possible. Okay, know your priorities. So back to bubbles. So this orange line here denotes the big bubble of this building. This one over here is a little bubble of this one particular apartment. So there's several little bubbles that make up the big bubble. Which one do you address first? You're always going to address the big bubble first. And honestly, we do that because that's how construction happens. We get the building watertight first, right? I mean, that's obvious. So this is what's called your exterior air barrier for the building. And again, look at this in 3D. We're just looking at the plans now, but it's a 3-dimensional shape. And then once you've established that and got that all sealed up, watertight, all the inspection verification requirements are met visually, then we start focusing on the little bubbles, and that usually comes down to, you know, the drywall, the interior air barrier, as well as ceilings and floors in a multifamily building. So anyway, when we do the testing for compliance, for compartmentalization, we'll do it on a little bubble basis, on unit by unit, not on the big building. If you're doing passive house, they will do that, but just by the way. But for compartmentalization, it's just little bubble, little bubble. Okay, so know your approach. So the air barrier is not an air barrier. It's not one particular material. It's a system of materials working together. It's not like, oh yeah, we specified this fancy membrane, we're good. No, you're not good. You have to think about the connections of that membrane, places where you don't have that membrane, et cetera, et cetera, et cetera. So again, we talked about the exterior air barrier. In this case, it's this is a zip sheathing approach. Oops, this is a tie-back approach. We lean very strongly toward something like this because a material like this, while it can be an air barrier on paper, and as far as the manufacturer is concerned with regard to their installation instructions, it is really hard to achieve in real life. So again, we're not trying to sell you one material over another, but our experience says you'll be more successful with, you know, integrated air barrier products. Liquid applied is also another good approach where, you know, the whole building just gets gooped with liquid material that is, I hope, to the right thickness, the right number of layers, and, you know, seals all the cracks and holes. Your interior air barriers, for example, in this picture up here, this is some draft stopping. Your air barrier is a combination of fire caulk, drywall, regular construction caulk, I should say sealant, OSB subfloor, this last piece of this wood floor truss, this top plate, and actually the wires and pipes themselves are actually technically part of the air barrier in this case. So it's a kit of parts, not just one thing. Okay, so zooming again in on a single apartment. So sorry for flipping the orientation. This must be from a different project. Our exterior wall is down here, demising wall here, corridor wall here, and another demising wall here. Nice simple rectangle. So first, our suggestion, very strong suggestion on the way to achieve compartmentalization is to focus on this outer perimeter of the apartment. Some people may say, oh, well, if you seal every penetration inside the apartment and you have a air barrier on the floor and blah, 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 you should pass a blower door test. Yes, that is true theoretically, but we've found that if you can establish a tight perimeter, I don't know what the military term for that would be, but basically, if you can stop the air out here, then you don't really have to worry about anything in here in the middle of the apartment. And what that does for the contractors is allows them to chase fewer items. You know, we make, as architects and engineers and builders and raters, everybody deals with thousands of tasks a day, and boy, the fewer tasks we have to deal with, I think the better we can do with them. So we like to say, if you can establish a good perimeter around your apartment, then you can just not worry about anything inside. Sometimes it works better than others. But at these four corners, here's a detail that shows how we are sealing the drywall to the first stud. Sorry, this doesn't exactly, yeah, that's pretty much corridor on this side here, apartment here, apartment here. That's blowing up this detail right here. So the first question that gets asked is, well, why do we have to seal to the framing? Why doesn't the tape and mud do anything for us? And I'll tell you exactly why. It's because, believe it or not, and on paper it's not obvious, but you will get air leakage between the framing and the drywall. No matter how tight that connection is with a screw or a nail, you're going to get air leakage through there. And what you don't want is air from out here in the corridor to get in here into the demising, or to the corridor wall, which then gets into here, the demising wall, which will eventually get into here, apartment B and apartment A. So again, I'm going to erase all this. The key thing to take away from this detail is this right here, and this right here, and this, which should be covered by your fire stopping anyway. And this line is meant to indicate a wire or a pipe or something. But so first piece of drywall comes in. Oh boy, my drawing skills are really bad today. Sorry. And on this side too, this piece gets cocked to the first stud. This piece gets cocked to the first stud. And then piece number 2 can come in on the demising wall. And then you get the tape in the mud as a last step. So if you wanted to flip this around in 3 dimensions, it's the exact same detail. So let's say this, let me erase my markings, hold on. So let's say this is a ceiling, this is a top plate. If we don't want air from up here, wherever that air is coming from getting down in here, which will eventually get into there, we have to make sure we are sealing the drywall to the framing before we seal drywall to drywall. Very basic, but as you're going to see it, we're going to repeat that over and over and over in different locations. So let me erase my markings. Speaking of different locations, so instead of just looking at the corners, so let's say we've got the corners squared away. Now let's look at every time the drywall on this big rectangle here is interrupted. So it'd be interrupted, for example, also at an interior partition connection. Same deal. Where this piece of drywall stops when it hits that first stud of the interior partition, that's a place where air can eventually leak in. So we seal that to the framing, you put your second piece of drywall in, tape and mud that, you're good to go. Same thing on this side. Okay, so if you're having a hard time visualizing it, keeping in mind that if you could theoretically take each apartment in the building, magically pull it out and dunk it underwater, I think it's pretty easy for most people to picture how you're going to get water leaking in everywhere. Every single hole in your drywall, every place the drywall stops, at the floor, at a door opening, at the ceiling if it's not caulked to the top plate, all the way around, you're going to get air leaking. You're going to get water leaking into the apartment, and air is going to do the exact same thing. It's exact same thing. It has a driving force and an opening requirement, and if you got those two, you're going to get water leaks, same as you're going to get air leaks. So I don't know. Try to keep a this in mind as you're standing inside an apartment looking around. Okay, where am I going to have air leaks? So just real quick, going back to, oops, let me erase these markings. Okay, so again, if we've got this perimeter, 4 sides of our box, and we're just looking at 2 dimensions, but let's say we're isolating air from this assembly from getting into this assembly, and we're isolating air from this assembly from getting into all the interior partitions. The last step is to seal any other holes or seams in that perimeter drywall. So in your ceilings or walls, you're going to have access panels, which we'd seal the cover panel to the drywall and then put gaskets on the door. If you shouldn't really have access panels in corridor or demising walls or exterior walls, but once in a while it does happen for whatever reason. If they're in interior partitions, ideally you don't have to care about them. Any plumbing penetrations through the walls, this is under a sink, for example, penetrations through the floor. Here's a big one, electrical boxes. This is the toughest one for people to wrap their heads around because it's a multi-step sealing process. At the pre-drywall stage, you're sealing all the screw holes and unused knockouts. It's a lot easier on like a plastic box, like a beige box, it's already a fire rated box, versus a blue plastic box, which has the knockouts that you can see daylight through the knockouts. Those are tougher to seal, but either way, you've got to seal everything in the box. Metal boxes are the toughest. And seal all penetrations into the box, so obviously your wires. And so those 2 things happen at the pre-drywall stage. At the drywall stage, after the drywall guys zip that out, you're also going to have usually electricians, sometimes a painter, sometimes a different sub entirely. They're going to caulk the edge of that box to the drywall. And basically what that does is it turns this box into just sort of a wart or a bubble on the face of your air barrier. So ideally you don't have any air from wherever behind that box from leaking through there, because the cover, the plate on there is not going to stop air leakage. Even if you buy the ones with the gaskets on them, they don't work very well and doesn't stop air leakage, around the switch or around the outlet itself. You're going to get air leakage through the device. So this is the way to go. I'm going to actually take this out of our air sealing guide because I actually do not recommend that. On that note, all these details are from an air sealing guide that we published a long time ago. They're in need of updating, but so it goes. But they are available to anyone for free. We'll provide a link at the end of the presentation so that everyone can download if you want. And I have to apologize to people who have been submitting questions because I haven't been paying attention. I've just been talking too much. So there's a couple of questions. Just one question, actually. Isn't this outside of the compartmentalization envelope of the unit, since the drywall around the perimeter is the air barrier? Benjamin, ask me that question again, please. Since I skipped ahead of what slide you were on, I'm not 100% sure what you're asking. This is for the corners of the unit, air sealing details. Okay, hold on. So let me go back. Oops. I guess I'll have to erase all my markings. Hold tight, hold tight. Okay, so let's see, could you get away with, I think what he's asking is, could you get away with not sealing these connections? Could you just say, well, I don't care if air from this assembly leaks into this assembly because I've got my nice tight drywall here, and let's say theoretically I'm sealing all of my electrical boxes and I'm sealing this wall to the floor and I'm sealing to the ceiling, et cetera, et cetera. Yes, that's the question. Great. Yep, theoretically. But I would say that we've had the most success by isolating assembly from assembly because in construction, nothing is perfect. I tell contractors all the time, aim for the stars, land on the moon, right? It's not even belt and suspenders. That's not the right metaphor at all. It is the fact that we've got to hit, if there's 100 holes, I mean, very good construction quality says that the crews are going to seal 90 of them. And because basically we need multiple layers of resistance. We need to have this outer, we need to have each assembly isolated from the next, and then we need to have these assemblies isolated from this space in here. That is the way that it's going to be most successful. So theoretically, yes, you're right. If you seal this drywall, just the drywall itself with the perimeter, you might be okay. I wouldn't rely on that. We'd never rely on that. And we still have plenty of projects that have trouble keeping on top of the subs to make sure this work actually gets done. So to go back, not to beat this dead horse, but here's any duct penetrations and takeoffs through your perimeter, sealing your millwork to the drywall, which is the part of, I think, pretty much every painter scope, although they always miss the top of the doors and windows just because they figure no one will see it. But when we have failures in blow door tests, I see it. So remind your painting subs that they need to seal that at least. And then here's a P-tack sleeve. The trick about a P-tack sleeve is sealing the sleeve itself to the exterior and the interior barrier before inserting the unit itself, and making sure that the unit fits in there nice and tight. Okay, that was a lot. No more questions. Good, I'll try to remember to keep checking. Architects, this one's for you. You should choose details and specifications for each project. Like I said, you borrow our air sealing guide and use it however you want. Plenty of architects will copy and paste details from our air sealing guide straight into their drawings, and they'll have 2 big sheets of air sealing details, courtesy of SWAT, and that's perfectly fine. But what happens is the construction team usually has a hard time interpreting those, because the way our air sealing guide is composed is as a kit of parts. You are given options for air sealing. It's not step A, B, C, D, E, F, and G. Do this, this is your scope of work. It is A through Z. Here's one way you can do it. Here's another way you can do it. It's a kit of parts that you need to assemble. You can't just say, okay, here's a bunch of details, you guys figure it out. That almost never works. So be sure you're welcome to use our details, but I suggest using them as inspiration, not as a literal copy and paste. You should definitely require unit by unit testing. I don't know of any programs that would allow you to meet a compartmentalization requirement by doing what's called guarded testing. We'll talk about that later, but and definitely not whole building testing. Obviously, some codes will let you do that, but Energy Star, LEED, Passive House, etc. No. This maximum 0.3 CFM per square foot of enclosure area is, like I said, what's in your Passive House for compartmentalization, Energy Star. This is 0.23 for LEED if you have big units. Either way, just make sure you know what's required by your compliance path or standard. And be specific, be super specific if you want. And this again is in our air sealing guide. For a gap that's 1/4 inch or less, use caulk. For a gap that's 1/4 inch or more, use foam or some other expanding material. We found that the caulk will crack, it'll shrink if it's put in too deep or too big. So that's where that comes from. Use appropriate sealants, low VOC, high temp, fire rated if necessary, etc. Make sure you get approval on those before you let your subs use them. This may sound stupid and fussy, but it really matters. Clean out your cracks before applying the sealant. If you've got enough gypsum dust on the floor as you're trying to seal the drywall to the floor, the caulk is just going to seal to the dust. It's not going to seal the floor itself, so it's not going to be very successful. There's also some new products out there, which actually aren't that new anymore. Sealants and tapes. You Passive House folks really have been leading the way on introducing those products and getting them worked into scopes of work. All right, so here's one for everybody. This won't be successful. Compartmentalization, meeting the requirements, will not be successful if everyone doesn't own at least their part of the task. So I love the body language here, arms crossed, looking at each other, you know, who is responsible, right? Architects, if your drawings and specs provide clear instructions for the design, construction team, then theoretically you're covered. Construction team, I would suggest putting one person from your office in charge, from the general contractor's office. You know, you folks are out there dealing with dozens, if not more, people every day from real early and some real early in the morning to sometimes late at night. All different weather conditions, all different times of year. You know, COVID was just like crazy. So I know you've got a lot going on, and so it's super easy for this to fall through the cracks. That was a pun intended. It didn't really land though. You really have to put, I say one person from your office in charge of writing all of the subs and making sure that they're doing their air sealing. And I would say you should check. If someone says they're done with their work, you check it, and you double check it, and you triple check it. Because a rater like me is going to give you suggestions and help you with how to succeed, but ultimately the verification comes down to us doing a blower door test. And if we roll in at project completion, everybody thinks they're done, and tenants are going to move in soon, and we fail blower doors, it gets real ugly. So you really got to own this. And one thing I'll say is that done, if somebody tells you something is done, it doesn't mean it's done well. I think that applies to everything in general, but it's especially true for air sealing. We did have a question, Peter, do dryer vents require special treatment? No. For dryer vents, our approach is to, you know, obviously not suggest any sort of screens on the outside or grid that would catch lint. A backdraft damper is always recommended, but otherwise you treat that duct penetration through the envelope of your apartment just like any other penetration. Okay, design exercise. Okay, everybody go do some jump jacks. 12:42. Did we start at noon? Okay, so we're halfway through. Does anybody have any questions before we keep trucking through? It looks like we've got pretty good engagement here, so I don't think I've lost too many of you. Okay, moving on then. So, first of all, we're just going to run through another example step by step, rather than me giving you conceptual things to keep in mind. I will run through a compartmentalization review with you like I would in any plan review, which is a typical part of our scope. So, number one, define the enclosure. So it's just a whole new project here. So again, we've got a demising wall, we've got a corridor wall with a little jog in it. We've got another little jog at the door. Architects, I know why you do that, but kind of has more complication than I think it's worth sometimes. Okay, corridor wall continues, then it turns to our demising wall, and then, this is kind of an interesting detail. Then it meets our exterior wall. So we got a window, we got a jog in the exterior wall. So there is, in 2 dimensions at least, our perimeter. That is our enclosure. And if you remember from when we started the presentation, which assembly do we attack first? Anybody? Exterior. Got to nail down that air coming from outside first. In this case, let's just assume that we're using a air barrier impregnated sheathing material, you know, like your zip. And so that basically extends past this apartment in both directions, right? But we've got tape on the outside of our window flanges here and here. We've got tape in the corner connecting these pieces, another corner. Oops, I should have highlighted. Here's a corner, there's a corner. All those connections between one piece of sheathing and the next should have tape. And the tape, by the way, needs to be rolled on with the right amount of pressure, not just with the hand. It won't stick forever if you don't. So moving down, another window. We're taping around that window. We don't have any mechanical or electrical penetration shown on this drawing, so we're not going to worry about them, but I bet they're there. Okay, so anyway, that's the big bubble, right? That's a big bubble. Now we're going to let's see. Yeah, oh, I'm sorry. Let's look at that in 3 dimensions. Okay, so let's say it's a slab on grade. You got your, let me use a highlighter or a laser. You got your bottom plate, you got your slab. You have what we're calling here a foam gasket, otherwise known as sill seal. Sill seal is not an air barrier. I know your concrete crews try to do a really good job and keep everything straight. You know, I would love to imagine that your wood coming off the truck is also straight. Neither of those things is true. Neither are straight. They're going to do this. They're going to do this. And this foam gasket's purpose is to just be a capillary break. It is stopping moisture that's in your slab, a lot of moisture in a fresh slab, from getting sucked up into this wood and then causing havoc inside this wall. So just FYI. That's what the sill seal is for. So now, isolating outside from inside. Let me go back to my pen. So we got air out here. We don't want it to get in there. Here's our zip air barrier. But what happens? It stops right here, right? So theoretically, air from out here, given a good stack effect, wind, any sort of driving force, is going to push air in that gap between the face of that plate and the sheathing. I don't care how well it's screwed or nailed or whatever, it's going to happen. So that's why we do this on the inside, or we do this on the outside. Tape the bottom of the wall to this poured concrete, which is an air barrier, by the way. And that will keep, again, outside air from sneaking in right here into that wall. Now that's not happening anymore. Great. But like we said, we want to isolate each assembly from each other and from the space, from the apartment. So here's our interior air barrier that again stops right there because you know, we're supposed to keep the drywall off the floor, right? And so this shows a really big gap. And so I've got a piece of, or a bead of caulk between the drywall and this bottom plate, and then I've got a bead of caulk between the bottom plate and the slab. This theoretically could be done with one big glob of something. EcoSeal is another good approach if anybody knows that product and its kin. But basically, so we've stopped air from leaking from here into here, and we're going to stop air from here from leaking into here. This connection between sheathing and the plate, and this connection between the plate, the drywall, and the slab. Any questions about that? And architects, by the way, you see how this slab installation goes to the top of the slab and connects with the above grade wall air barrier? Don't forget that. Pet peeve. Okay, moving up the wall. This detail is an enlarged section view of the edge of a floor truss. So here is the subfloor for the unit above. Here is the drywall for the unit below the ceiling. And then, you know, this in here is a truss cavity, let's say. My drawing is getting better. Thank goodness. Okay, so again, where do we start? Exterior air barrier. Let's worry about air that's out here from getting into there. So if this is a nice taped, impregnated sheathing material, oh, we've got to hold this penetration. So that should be sealed up. Before the caps and the trim go on, by the way, contractors, this is a huge, I don't know why this is so hard. You have to sequence the mechanical rough-in, and I know it's not, nothing's perfect, but you got to get the mechanical guys to at least penetrate the exterior air barrier or the exterior sheathing with this duct first, and seal that. Then we're good. Then you can worry about your trim and your caps and all that stuff. Okay. Anyway, the sheathing keeps continuing down, and that's your exterior air barrier. That's it. So as far as the big bubble is concerned, we're good. Just making sure we've got all of our penetrations and seams in the sheathing sealed. Okay, that's the big bubble. Little bubble. Well, let's ask a question. If this is, oops, this is the floor of the unit above, ceiling of the unit below, these are our trusses. Which apartment does the air in this truss belong to? Typically in our projects, the air in here belongs to the unit below. That's the typical approach, because when this truss hits a demising wall or corridor wall, we've got draft stopping there. And so we'll seal that up and any penetrations, we'll seal them too, because that's already required for fire code. That's already getting done. It's already in the scope of work. Someone's already, you're already paying for it. Everybody knows how to do it. That's usually why we include this volume of air here in the bubble of the apartment. Let me get rid of my scribbles. So in that case, we've got our exterior air barrier, and then all of this is one big air volume. Really what we're concerned about is air from the unit below from getting into the unit above. And that's when this and this come into play. So you'll get this air from down here will sneak up behind the framing, between the framing and the sheathing, and up into this wall cavity. And again, theoretically, if this drywall is perfect, then we're not worried about anything, but it's not going to be perfect. So we want to minimize air leakage from below, from getting into this assembly here, so that it doesn't go into the apartment there. And so that means that this, this, and then all of this, and this, in that scenario would not be necessary. All we're caring about is the air from down here, not making it past that line right there. We don't care if air up here sneaks into this cavity down below. I will say that we still do recommend sealing this and wire penetrations, which by the way are already fire stopped, and this right here. Because again, the more times you can put a roadblock between one assembly and the next, the better your results are going to be. So I know I kind of did a juke on you there. So technically we wouldn't say, oh yeah, you should really, let me rephrase that. We would say if you are trying to save costs, which often becomes an issue when we are dealing with air sealing on a project where, let's say, the design team and the construction team were not on the same page, and then Raider guy shows up and says, well, all right, you guys are gonna have to meet this test, meet this requirement, how are you gonna do it? And then everybody, remember that picture where everybody's got their arms crossed and looking at each other? Right, so we recommend making this sealed up down here as well as this sealing up here, because minimizing air from here into down below will help. So it all depends on how freaked out the construction team is when we have this conversation. Sometimes we'll say, okay, fine. Spend your money here. Don't spend it down here. You, in theory, would be okay, but whatever. Sorry, not to send mixed messages, but sometimes it turns into a horse trading session. Okay, top of the wall. This just happens to show an attic, an insulated attic. So we have insulation up here. Again, exterior air barrier is always where you start. Get that sealed to the top plate. And then your interior air barrier, or actually this is still your exterior air barrier, this drywall underneath an unconditioned attic, that's also an exterior air barrier technically. So you're sealing that to this top plate, and if you got any penetrations coming through there, you're sealing them too. So going back to the concept about an air barrier not being one product, but an assembly of materials, you've got sealed sheathing, you've got sealant, you've got top plate, you've got drywall, and then you've got more sealant. So 1, 2, 3, 4, 5 pieces, 5 different things comprise of an air barrier at this intersection. Here's a question. 2 questions. If there's resilient channel at walls between units, is there detail to ensure the air does not enter the floor assembly? Right, previous slide. Right, great question. It applies to this slide too, because oftentimes we will have resilient channel up here. Honestly, I don't think it's required if this is an attic, but it might be required if that's a flat roof that doesn't have draft stopping. I'm not sure. I think it depends on construction type. Anyway, you could very well have had channel up here. And really what it comes down to is, oops, undo that last one. Sorry, hang on. There we go. It really doesn't change anything. So if your drywall is down here instead, and this right here is your resilient channel, and this right here is your drywall, all you do is seal the drywall to the top plate down here instead of up there. So the shape of your air barrier here is up, over, down, and over, instead of just straight across. Okay, then another question. Oh, and so that applies to walls too, by the way. Just think of this in the other direction, same deal. The sealant between the bottom or top plate and the sheathing is interrupted by the stud. Is this material right? Oh my gosh, I've been scratching a lot. Okay, let's just pretend that this is, just forget all this other stuff. Let's say stud, drywall and sheathing, right? And we were saying, now we're in 2D here. You're sealing this connection between the sheathing and the stud, and then you're sealing this connection between the sheathing and the stud, and you're going on, da 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 da. What about where the stud interrupts our sealant, which comes out to be what, about 16 inches on center. This is an inch and a half. What is that, 10% of the wall? We just eat it. It's going to leak. I mean, you could, if you wanted to, go super crazy and go around all sides of the studs. Nobody does that. We have found that, again, it's this shoot for the stars laying on the moon. You don't need to do that if you're doing a good job with everything else. Hope that answers your question. How do interior smart films work into this? Well, that's a great question. Let's see, let's go back. I mean, they're all great questions, by the way. Okay, here. So here we're looking at a smart interior air film. In this case, you can see this blue tape is sealing one sheet of the membrane to another sheet of the membrane. In this case, your drywall can no longer be the interior air barrier. Your membrane is the interior air barrier, which is great and totally doable if you can afford it. Keep in mind that this air barrier is still going to have, if there's a sconce here, there's going to be a hole there, right? This picture is a little misleading because really the only thing penetrating this interior barrier is these, furring strips up on the ceiling. This must be against attic, I think. This is not from one of my projects, but yeah, if you can get that all sealed up, then that can be your air barrier. And the cool thing about this is that you can actually test it. You can get this air barrier installed, sealed up, and tested before you start any drywall. So you know at the pre-drywall stage that you are already in good shape. So that to me is the biggest benefit of using these interior smart membranes, or not interior, but smart membranes in general. It's just an extra cost that for most of my projects, they can't afford. The smart side of it has no bearing whatsoever. Smart barriers, smart means that it's smart enough to let moisture through and not air, is basically all that means. So this is an air barrier. As far as we're concerned, we're not worried about vapor or anything like that in this for compartmentalization. At the attic, how is the B bead installed? Assuming after the sheathing. Oh, B bead. Okay, I think you're referring back to the detail. At the attic. I'm getting there. Hold on. Okay. Let me clear out my marks. B. B is this one. Yeah, that's this one. Great question. That is almost always done by some poor sap crawling in here after the building's watertight and caulking that connection. It can be done. There are plenty of builders, especially the passive house guys, who will, have some sort of pre-installation of an air barrier up here that they'll seal to out here. and then they'll seal to in here, and it's good to go. That is sort of a higher level of construction than I typically see in the New York City area or tri-state area. We can definitely do that. In theory, you could use tape over the top from the outside too. But another way you could do it is from below. So let's pretend that these headers aren't here. Let me erase my markings. All right, and let's just imagine this sheathing going down, drywall is going down, and let's say we just have top plates here, right? If you sealed it here and here, between the double top plates, and here to the drywall, then your air barrier in this case looks like, change my color, change the color of my pen, ink color. Wonderful. It goes from, the shape of it now is your sealed sheathing across the bottom of this plate, across the front of these two plates, and then across your drywall. So that's another way you can do it. But again, it's getting interrupted every 16 inches by a stud. So I don't think it's as good as sealing it from the top. And the way we seal this connection right here is, the drywall, in my experience, always goes on first. So that's easy enough to both do and verify before any wall rock goes on. Okay, we'll keep going. All right, so now we're going to isolate interior partitions. This is a slightly different version of that plan. So where are our interior partitions? We got one here. Oh, I changed the blue permanently. Okay, here, here, here. We already addressed the corners, let's pretend. Here, where this closet hits, ooh, right there. Here's a little stub wall to hide the refrigerator. Here's a little wall under our island, and here. So there you go. There's all the locations where the interior partitions intersect the perimeter air barrier. Also, don't forget, there's probably something funky happening under this tub too. But anyway, the detail that we discussed previously is this one. Again, big takeaway, the most important thing is to stop the air leakage between two materials with sealant between those two materials. I'm not going to dwell on that because I think we dwelled on it pretty long before. This is another way to do it, which I think is by far better. And you steel frame folks, this is normal for you. They'll leave a gap here between this wall and this wall so that you can run a piece of 5/8 rock through there first. And so then the rock is not stopping, right? It's continuous. Let me go back. So here, the problem is that the drywall stops when it hits that first stud. That's why we've got to seal it. If that doesn't happen, if the drywall goes right past, then all you're really worrying about is sealing any penetrations through there. So again, very common in steel, light gauge steel, almost never happens in wood frame construction. I think the framers just gotta have wood nailed into wood. That's just the way it goes. But there are tricky situations. Yeah, there are a few in that plan. This is what I call a flyby wall. So what's happening, this purple circle right here, and by the way, this is the demising wall, which is, that is one small apartment there. This interior partition is in line with this demising wall. So here's what it looks like up close. And if you're not paying attention, the drywall guys are just gonna go, whee, put one big sheet across there. And obviously they're gonna come in through the closet and just keep going, right? That's obvious. But the problem is there's a connection here between the interior partition and demising wall that's not getting sealed. I'm gonna switch back to red. Okay, so what you've got to do is if you're not going to be able to get a piece of drywall here first and mud that and then build this wall, then you've got to stop this piece of drywall right here. So you're drywall to there, and then you're sealing that to the framing, and then you can put this piece of drywall on, bring it around, bring it here, stop, seal the other side of that stud, and then keep going. So that seems super fussy, and I understand that. But if you don't do that, then you're going to have everything that's over here getting into here. And by the way, there's a washer and dryer hookup right there. There's ducts, there's pipes, there's wires, and it's a tiny little closet, and you are going to be chasing ghosts. Where is that air coming from if you don't knock it down at the perimeter? I'll wait a second for questions. Cool. That's what I call a flyby. I made that up. You're welcome to use it. Yep, don't forget to think in 3 dimensions. For as far as floors go, most wood frame construction is going to require gypcrete here, which is great as far as an air barrier goes, except where there is no gypcrete. So for example, if you got a chase, let's say you've got a tub right here, and this is a chase with a bunch of pipes and wires and ducts and stuff going through it, they've got to gypcrete inside that chase. They've got to gypcrete under the tub in order to get a consistent air barrier. So don't forget that. Also, gypcrete isn't perfect. Sometimes if the rock is too short on the walls, if that little isolation strip, that little seal gasket that they put in isn't done right, you can get air leaking from one floor to the next at the edges of the gypcrete. So just conceptually, our typical approach has been to draw the air barrier like this. So the floor of the unit above, exterior wall, obviously, the floor of your unit, and then the corridor wall. It's typically how it works. But if you wanted to, oops, I'll come back to that flyby question later. If you wanted to seal, let me draw this. If you wanted to isolate for whatever reason that floor truss cavity from your apartment, you can definitely do that. It's just that you've got to start addressing these connections here, which looks like this. So here's apartment A, apartment B. Here's your double frame demising wall, very common detail. Here's your top plates, big old gap between them. And so we usually just say, you can use expanding foam if your inspector allows it, or just give yourself a piece of wood there and seal penetrations and then seal it to the top plate. And then obviously you're sealing this drywall studs, and so your air barrier looks like, need that blue pen back. So it just goes across, jogs up a tick, jogs down a tick, and just keeps going. And that'll stop any air from here from leaking into there. And this is what it looks like, you know, here. This is some pretty successful air sealing. Some installers like to use drywall adhesive. Sometimes it's required. The reason I don't rely on drywall adhesive is because it's impossible to verify. And those guys have a tendency to go 1,000 miles an hour. And it's just, you don't know what got done or what didn't. Is it 90% complete? Is it 50% complete? How often did the caulk gun go and, you know, blurp out an air bubble, and then, you know, there's your gap, right? So also keep in mind, if you're using your ceiling drywall as your air barrier, you know, any recessed cans, any penetration through the ceiling, you got to seal. If you got a sprinkler head, nothing you can do about that. And also here's an interior partition with a bunch of penetrations through it. And this is where it gets really tricky. If you've got a bunch of penetrations and then, you know, getting the fire stop between them. Sometimes they're just a big old cutout that needs to be filled sometimes, yada, yada. But again, that's theoretically already in fire stopping scope. So hopefully you already own that in your contract. Here's inside a chase. So again, just like we talked about, not forgetting Oops. Not forgetting to seal gypcrete inside chases. You also got to make sure you've got a lid on your chases, and that lid is sealed to the adjacent drywall. I'm sorry, adjacent top plates, so that you don't have air from up in the ceiling leaking it down into this chase, which is going to leak into your bathroom via the valve at your tub in your shower. Okay, for the flyby, why wouldn't you be able to concentrate on the other apartment to air seal that side, which would be easier? Right. Because, so they're saying, well, yeah, why not? Well, you could, but we've found that you have to address both sides of this wall. You have to address this side for the sake of this apartment. You have to address this side for the sake of this apartment. In concept, if you wanted to go unit by unit and decide which side of the wall is your air barrier, that's great, but that's expecting way too much of your construction team. Not to say that they're not capable of it, but it's just a level of complication that's not probably going to pay off. In fact, we oftentimes will decide with contractors, who are paying for the work, just to dumb it down, even if there was an extra bead of sealant that wasn't necessary. They would rather have the peace of mind that they're not going to confuse their subs by say, do this and this, but not that and that. Oh, and do this too. Like sometimes they just say, just do it all. And that way we know it's all done and we don't have to worry about some new guy who came on, who wasn't there for the training, doesn't know. And, sometimes there's just such a turnover with your crews. It pays to keep things simple. But conceptually, Victoria, you are correct. You could do it that way. So the draft stopping, again, is this sort of like vertical solid material between the floor cavity in one space and another. So here is on the apartment side, here's a corridor side. And your air barrier in this case, if it's done correctly by sealing all these connections and penetrations, should look like that red line. Same thing for unit to unit. I mean, I'm just tracing what the air barrier is for each apartment. Yeah, and theoretically, you could just do one side, but it's not going to play out in the field. Here's what it looks like if you were to turn that section 90 degrees. You're cutting through your trusses, looking at the draft stop. Again, solid material, ceiling penetrations, and then you're kind of picture framing between your floor structure. A couple of examples. I don't know why they did both the drywall here and they're doing the wood there. Maybe it was just a experiment or something, but one thing I will say is that here's a penetration that didn't get sealed. So you really got to get somebody whose job it is to be the air sealing person and to really push all the trades. So again, these are our drywall penetration sealing details that you would incorporate after drywall, after you've done your sealing to the framing, et cetera, et cetera. Okay. I have a whole nother section on townhomes. It's a 113. Are people saving their questions, or have you been submitting them as we've gone? All right. No one's scampering to ask another question. We can always come back if necessary. So I'm just going to move forward. Townhomes are tough for two reasons. You have to compartmentalize them. You typically cannot do the enclosure-based testing target, which is going to be almost always easier than the volume-based target. So your CFM 50 per square foot of enclosure versus your ACH 50. In my experience, most times the local jurisdiction is going to require you to use the ACH 50 metric, which is in most places pretty tight. And the problem is in townhomes, it is this right here, this right here. These are all three different apartments, right? You see the green shaft liner dense glass sticking out there. Those are super hard to seal depending on how you do it. And how most people do it is they'll do this. They'll do this 2 layers of 1-inch gypsum liner panels set between steel C&H studs with aluminum clips at floor and ceiling, continued underside of roof sheathing, etc. That is not an airtight assembly. And this is what it looks like. Here's your H clip. Where's a C? I don't see a C, but that would be a horizontal. But basically, you're going to get air leakage through here if that's not sealed. Every single one of those seams around every piece of this shaft liner is going to leak. And so basically, you don't have a choice but to rely on the drywall as your interior air barrier and your first and only line of defense in this assembly. And look at this here. Does the drywall run past the stair stringer? Nope. So now your demising air barrier on this wall is the drywall, obviously any penetrations through the drywall, and now it's the stair stringer, and then it is whatever is in this dead space below this stair. So it just gets super, super complicated above and beyond the fact that you've got all these leaks at the H channel. And then here's a detail of, in plan, that you architects, I know why you do it. You jog the building, you know, you make this one bump out, this one bump in, this one's got both a bump outs. It's a double bump out, this one's a bump in, and how the building profile jogs, both in plan and in section. You know, usually the site isn't flat, so here you're jogging down, here you're jogging down a little bit more. Oof, tough to flash that one. Anyway, yes, I know simple boxes are not the easiest to design, but when you start to have, you know, this stuff happening, your inspectors are not going to let you seal any of this. You're basically going to rely on just this drywall here on that side and just this drywall here on this side to be your air barriers. It can be successful, but you're going to run into, do I have a picture of it? No, I don't. This is going to get penetrated by all kinds of stuff, pipes, wires, boxes, framing, stair stringers, everything. So it's hard. So I'm just going to keep whining for another half second and then show you what I think you should do more often. Here's a section where the building steps down between 2 units. Very, very common. Again, you're basically relying on this one layer of ceiling here for this unit to the left and here for this unit to the right. There's really nothing you can achieve by addressing that shaft liner. Here it is at the top of the building. Again, super hard. Even harder when you've got to stop air. As part of an air barrier, you've got to stop air from this attic from leaking through this crack and down into the building. This connection right here, and this has been in the Energy Star thermal enclosure checklist requirement since the beginning, since like 2006. Usually, we will have cooperation from the building code enforcement people to get at least this bit sealed up and this bit sealed up, but there's almost nothing we can do about stopping any air leakage that might be between these 2 pieces of gypsum. If anybody, can the clips be taped is a question? Yes, they can be taped. If you want to pay for that, and then also coordinate it to happen before these wood walls are built, go for it. But good luck. It's a good idea. It's a very, very good idea. We tried it. We still try it once in a while on projects if that's all the team seems to want to do. And theoretically, it can work, but all right, so the solution, here we go. Like here's some blocking between trusses. Now if you're gonna rely on sealing the green dense glass here or shaft liner, how are you gonna get to anything up here, right? It's already been blocked off. So mostly it's a sequencing issue. It's not necessarily even a problem in materials, it's sequencing. Oh, there you go. Oh, we did have a picture. There's some Tyvek tape. Is Tyvek tape approved for connecting this material to the metal to this material? I don't know. How long is this Tyvek gonna last? I don't know. Or Tyvek tape, I should say. Again, all kinds of funny things happening. Pipes, wires, awesome. This, I don't know how they got it approved on this project. This is where a demising wall hits an exterior wall. They got that. The code inspector let them do that in a fire rated assembly, which I very rarely see. Good luck on getting that happening. Here's a way you could do it with extra pieces of dense glass and, you know, sealing piece to piece. to framing. Again, it's all dependent on your building code person. So here's another similar project. This is a townhouse. These are party walls. What's happening in this? It was still a 2-hour assembly between one unit and the next. And they just did it differently. They, instead of putting the shaft liner in the middle, they've got 2 layers of 5/8 on each side. And they build that wall first before they got anything else happening on the inside. And they take it all the way up, they seal, they can always stop the drywall, seal it to the top plate, so we know we're not getting air down into this wall from the attic. Or they could, even if they want to, go all the way up here and seal this like that. And what that looks like is, here. So here they have sealed all the way to the roof. Theoretically, is there a seam in the sheathing up above here that could let air into this cavity? Yes, but let's not worry about it. So here you can see this demising wall drywall shooting straight past this truss. Hasn't been sealed at the roof yet, but, and then here's just a detail showing this drywall going right past any interior framing. Again, right past interior framing, you've got a gap for sound, beautiful. That is the way to do it. All right, so we have 9 minutes left. Al, do we have any more questions? I have a little bit more. I could just go for days with this stuff. No more questions? I'm not seeing any. Okay. How do we evaluate air sealing? So the pre-drywall stage is just visual inspection, typically, unless you're getting fancy and using, membranes and stuff like that. And at the final, we do the blower door test and visual inspection. Visual inspection is still for the exterior air barrier. That's a very prescriptive thing. Checklist, checklist, checklist. And the blower door is more of a performance thing. But that's how we confirm it at those 2 different stages. Here's a picture. Where are we worried about air leakage in here? All these spots. And this is just one corner of the apartment. So if you can get the concept down, it's not that hard to apply it. And mostly comes down to enforcement, honestly. Be methodical is really how you have to treat this. You can't wing it. I'll say that much. You're going to hurt at the end if you try to wing it. Here's some of the checklists we use. This is straight from residential code. Been in there forever and ever and ever. Does anybody actually check that stuff? Who knows? We do. Here's a manometer, which, just for fun, all it is 2 pressure gauges. Here's channel B, here's channel A, connected by a computer. It's really all it is. For anyone who's seen a blower door test done. Here's more information on guarded testing versus unguarded. So we're depressurizing this middle unit to 50 pascals. So you're going to have air sucking in from the top. So to negate that pressure, we would do a blower door up there. Same thing from this side. Boom, 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 boom. So you could actually say one reason most programs don't allow guarded blower door testing is not because of compartmentalization is a good idea, is that it's incredibly time consuming and expensive and hard to do guarded testing. Can't do guarded. All guarded does is make sure you're saving energy. It doesn't help you in these remaining reasons why. And so that's why LEED, EGC, Energy Star, that's why you have to do unguarded testing. Boy, those townhomes sure do look nice in the end, but God, are they hard to build. Okay, if you're asking for an infrared camera on site, then it's too late. Somebody screwed up, and you're going to be chasing every little CFM, every little crack. Yeah, so before someone says, oh, can you get infrared in there to see where our leaks are? No, do it right the first time. Okay, let me skip ahead to I'm going to stop presenting. Well, maybe I will keep presenting. No more questions? Keegan, is there anything else that you wanted me to add? Otherwise, I can give people 6 minutes. Actually, we do have some ending slides. I do also have just a bunch of examples of instances where these are all things. Here's if I can still read. Let me get a pen. If I can still read dense glass under the liquid applied air and water barrier, it's not on thick enough. All kinds of crazy things happening. These are all the places air will leak. There's a question, have you used air barrier in existing retrofit projects? Yes, it works great. I don't love the fact that any sealant that goes through a crack, it doesn't get stopped, just sort of like blows out into the world. Not in love with that side of it. I'll also say that you need to make sure you do a good job protecting windows. You really wouldn't want to do it after any finishes are in, because anything that doesn't, any of the adhesive or sealant. For those of you who don't know, aero barrier is, I'll back up, is a technology where you spray a mist of sealant into a pressurized building or pressurized apartment, and the mist finds its way to the cracks where the air is leaking out of that unit, and it sticks and it sticks and it sticks and it sticks, and it makes the hole from upwards of, I think, 3/8 or 1/2 inch big, and it'll seal it after an hour or 2 or 4 or whatever. And so it's pretty amazing. But yeah, there are definitely pros and cons, and there are definitely tips for doing it right. But yeah, it can be super, super effective. And the price is coming down too. All right, so these are just, I mean, I can go forever on this stuff. In summary, you got to understand why, how, and where air leakage is happening. Know your target, detail it and specify it architects, inspect and test it, and communicate it, and you should be just fine. Here, I'll stick on this page for a minute or two, is a link to our air sealing guide. And it's actually, I'm sorry, air sealing guides. We have 3 of them. One is for wood, which is what we talked about today. We have one for steel frame construction, and we have one for masonry construction. And yeah, they do need updating, but unfortunately, it's one of those things that just kind of gets pushed to the back burner when other fires are burning bright. Yes.
You could actually send the URL out to everyone in the chat pane, in the control panel.
Yeah.
So yeah, if you can send it to the entire audience. And while you pull that up, I'll just say again, thank you to the sponsors of Energize Connecticut for bringing this session to everyone today. And it is approved for AIA and BPI CEUs. So we will be sending out a survey after the session in the next couple days to everyone who was in attendance. So if you're interested in CEUs, there'll be a question for you in the survey there, and the recording will be posted to the Connecticut Passive House library of trainings in the next few days as well. So I think that's it from me, though. Steve, any closing thoughts?
There's just one more quick question. Can you speak briefly on closed cell flash on exterior walls? What that means is a thin layer, typically 1 pass, inch and a half thick, of closed cell foam, which is a air and vapor closed product, on the inside face of the sheathing before bats are installed. So you're seeing rough framing and your sheathing, and you spray closed cell foam on that. That helps you when you've got an air barrier that's not an air barrier on the outside, in my opinion. That's the best use of a flash coat of foam. So if you were using something like Zip, that's already sealed on the outside, there's really no point to do the flash coat. But if you're using something like Tyvek and they were using it only as a water membrane, not an air membrane, then that would be a great application for it. But again, you're not going to be able to do it most likely on your demising walls and your corridor walls. And so really it's only an option for you at exterior walls. Another question real quickly, would movement cause cracks and spray foam over time? In my experience, no. If it's installed properly, yeah, I guess theoretically it could happen, but if the foam is sprayed well at the right conditions and temperatures and right mix and all that stuff, yeah, it can happen. I don't know that I've seen it happen myself. But yeah, you're right. Wood does move and shrink and whatnot. Okay, so a couple questions there about spray foam. Okay, that's all I had. Well, it's 1:29, so
Perfect.
Yeah. Thank you, Keegan.
Yeah, Steve,
Thanks
so much for your time and your expertise, and thanks to everyone for joining today, and keep an eye out for the survey that we'll send out to y'all. Thanks, Steve. Take care.
You bet. Thank you. Bye.